In this video, we will see elongation of bars. So the first case is very simple, where there is a bar having cross-sectional area A and length L. We are applying load P in both the ends, so there will be stress generated, and the change in length delta L will be equal to PL by AE. The stress will be P divided by A. The second case is where there is a change in diameter from D1 to D2, and it's a tapered bar. Load P is acting on both the ends, so there will be uniform load, means every cross section there will be P load only. Now the delta L will be equal to PL by AE, but here area will be having pi by 4 D2 and D1 D2, pi by 4 D1 D2. So here instead of D square we have D1 D2. So if we take mean diameter, then it will be geometric mean. So D square equal to D1 D2, then D equal to under root of D1 D2. So it's a geometric mean of both the diameter. So this is the change in length in the tapered bar. Now the third case, here it is due to self weight. Now if you see the this bar, instead of load applied at the end, we are applying, the bar is hanging. Now there is a self weight of this bar, and due to which there is a change in length. So here if you see, delta L will be equal to PL by 2 AE. So PL by AE divided by 2, so it will be half, but here P will be the weight of this bar, which is equal to mg, and m is equal to rho v into g, and volume will be equal to area into length. So this is how the self weight case is there. In tapered bar, if you see, the same formula is there, wl by 2a, but here w is a weight of this tapered cone. So here the tapered cone, weight will be equal to mg, and here m will be equal to the weight or mass will be equal to this tapered cone. So if we see relation mass equal to rho into v, and the volume of the cone will be equal to volume of the cylinder, which is formed with area into length divided by this 3. So volume of the cylinder which is formed with area and length, area is the base of this triangle. So 3 times if we fill the cone, then we will get the entire cylinder of same area and same length. So volume of the cone will be volume of the cylinder divided by 3, and volume of the cylinder will be equal to area into length, so AL by 3. And this is same area and length, so volume of the cylinder and cone, base area of the cone and area of the cylinder should be same, and length will be same. So that is how we calculate the volume of the cone, which is equal to volume of the cylinder divided by 3. So like this, AL by 3 will be equal to volume of the cone. Here we have to put the volume of the cone, and then WMG, then W we have to keep here. So delta L equal to WL by 2A. These both formula are same, but here P will be equal to weight of the cylinder, and here W will be equal to weight of this cone. Now if we see this case, here these bars are connected in series 1, 2 and 3. The load P is acting at the ends. So now if we see free body diagram of 1, 2 and 3, then there will be 1, 2, 3 all having P loads, because load is same throughout. Now if we calculate stresses, then more area less will be the stress. So 2 is having more area, 1 and 3 are having cross sectional area same, so stress will be P divided by A here, P divided by A here, but it is not equal to the stress in the 2, because area is much bigger. So sigma 1 equal to sigma 3, which is not equal to sigma 2. Now if you say total change in length will be equal to summation of all this, delta L1 plus delta L2 plus delta L3. If it is compressive, then we have to subtract it. So that is how we have to take care, but here all the forces are tensile in nature. The other case is the same series case, but we have P load here, Q load on this surface, R load on 1 and 2 junction, and S load at the end. So if we draw free body diagram of all three, then S will have, see, this is not moving parts, so force will be on both the side, it will be same. So if S is here, then in one there will be S on the other side. So this will be the load. If we take any cross section in between, there will be S load on both the sides. So at the end also S will be there. Now if we draw a free body diagram of the two, then these these two loads summation should be equal to R. So here S is in this direction, here r plus s in opposite direction. So if we take sum, then r plus s minus s will be equal to r. So here, or you can take one cross section on 2 and you can check r and s are both in this direction in this particular cross section. So here on the 2 also r plus s will be in this direction. Directly you can say r plus s, here also r plus s. Now same will be on the other side because it is not moving. So to for summation of fx equal to 0 on 2 also, so r plus s, r plus s. Now here on 3 there is a clear cut load p is acting, so on the other side there should be p load. Now if we see the q load is there, if you want to find the relation, then we can directly tell that q is equal to summation of these two. So q is positive in this direction, so r plus s is in this direction, so r plus s minus p. So r plus s minus p equal to q. Q is positive in this direction, so whichever load is in this direction we have to take positive. So at junction between 2 and 3 there are r plus s and p load, so r plus s minus q will be equal to q in this direction. Delta l will be summation of all three, same as previous case. Now the last case will be equal to the case of parallel. So if there are, you see the blue color cross section and black color. So blue color is outer cylinder, black color is inner cylinder, and blue color is outer ring. So this is particular diameter having outer and inside diameter. It's a circular. So there are two materials, the inside is material 1, outside is material 2. The load p is acting. Now if you see on one cross section 1 there is a load p1, and on 2 there is load p2, and these both will distribute as per material property. So p will be equal to p1 plus p2. This p will be distributed, this p is acting throughout this cross section. So in entire cross section 1 and 2 the p is acting, so here it is 1, here outside it is 2. So it p will equal to p1 plus p2. Now if it is elongating it, then delta l1 means delta l of inner cylinder equal to delta L of hollow cylinder, which is 2. Delta L1 equal to delta L2. Delta L is PL by AE only, so P1 L by A1 E, because cross section is different, material of both this is different 1 and 2. So this particular cylinder is cross section of this. This is cylinder from side view. This is a cross section. Um, if we cut like this on the side of paper, and delta L2 equal to P2 L by A2 E2. So length will be cut, and the p by a is sigma 1, p2 by a2 is equal to sigma 2. So sigma 1 by e1 equal to sigma 2 by e2. So all these equations we get from delta l1 equal to delta l2. So here there is in series it is summation of delta l for total, here both the delta l will be equal. So these are some of the cases. We will discuss some more cases in future videos. Thank you for watching this video.